ProbStats kids, this is Dr. Callahan with week 16, Tuesday, excuse me. How are you guys doing? I hope you had a good week. So let's go ahead and take a look at this with your 3 warm-up log questions. Keep in mind that you guys are going to have to turn this in week 18, so in 2 short weeks, and you'll have 300 points added to your grade book. All right, so let's go ahead and take a look at your MS team for today. Your assignments, of course, is going to be on week 16 Tuesday, and every day you will have an assignment posted on there. Keep in mind you have to view the assignment in order for me to go ahead and mark you present, but in order to sustain your grade or increase your grade, you must go ahead and upload your assignment and turn it in. So this is actually for week 16 Monday. So today is week 16 Monday technically, but I'm making the video for week 16 Tuesday. So I'm just gonna go ahead and click on the assignment, create assignment. So if you don't want your grade to drop, my suggestion is that you need to highly make sure that you go ahead and have your assignments turned in and uploaded. Even though we're on distance learning, you're still required to go ahead and maintain that grade. Okay, so your instructions is to do the following. View the assignment attendance purposes, watch the video. Oh, and you know what, hold on a second. Let me go ahead and make sure I switch it over. There we go. Comment, fill, guided notes, take photo of your work and upload it to grade. It's gonna be 10 points every single day. I know you're like, well, 10 points doesn't seem like a lot, but it's 10 out of 10, so it's really 100%. And it's a weighted out of 10. So it doesn't matter if I weight it out of 100, it's still going to be 100%, you know what I mean? Versus if I do a 5 out of 5, a 10 out of 10, or 1,000 out of 1,000, it's still 100% if you turn in the assignment. Today's video will be always updated by 8:30, the day of the lesson. So obviously it's not there yet for week 16 Tuesday because I'm making it right now, but it will be uploaded on there. If you have any questions, I do have a daily Zoom from Monday through Fridays, 10:10 till 10:30. This is not going to conflict your other classes. It's during that independent time. It's not mandatory, but if you do have questions, please reach out to me. Here is the link, the code, and then also the password. So just keep that in mind. In addition, if you have questions about emails, this is my email as well. So you can go ahead and do that. All right, so 10 points. There are 2 ProbStats classes. And this is, of course, due on Tuesday. So it's all due the day of. So you don't have the entire week to do that. You do have a resource. Every day I will have the guided notes on the attachment. So if you need to print it out or something, you're welcome to do that, or you can just go ahead and do it on a separate piece of paper. That's fine with me as well. So today it's for week 16 Tuesday ProbStats guided notes. It's on central limits. So let's go ahead and upload that. What? The selected name is too long. That's ridiculous. Let's try this one more time. Okay, so I decreased that, so hopefully that'll work. Done and assign. Okay, so that should pop up then. All right, let's go ahead and go back to what we're doing today. All right, so with that said, let's go ahead and just get started with today's stuff. Christmas jokes. What goes ho ho whoosh, ho ho whoosh? And here are your little, it's a Santa caught in a revolving door. And what goes up, what's white and goes up? A confused snowflake. All right, haha. Anyways, let's go ahead and get started. So today, this is your breakdown. We're gonna go ahead and talk about probability and the central limit theorem. We're gonna go over examples 1, 2, and 3. Your homework tonight is gonna be on 5.4 part 2. You need to make sure you guys go to week 16 Tuesday to access that on the Google Docs, so make sure you guys have that. We will be correcting it tomorrow. And you do have a quiz tomorrow on 5.4, so week 16 Wednesday. All right, so first thing you need is I'm gonna have you guys do 2 colors, and then also you need to have a scientific calculator for today. And you also need to go ahead and have this sheet. Now you can download this on your MS Team. So let me show you where it's located. If you just click on week 16 Wednesday, you will have that there. Let me go ahead and share that. Here we go. So if you go to week 16 Tuesday, click on that. Do you see where it says? It actually doesn't say this. I didn't attach it correctly, so I don't know why it's not doing that, but that is super duper annoying. But that's okay. I'll just go ahead and manually attach it, so that's not going to be an issue either. So let me go ahead and attach this so that way you have it. Attach. Okay, so you do have the guided notes here. If you just click on the guided notes from your MS Team, you'll be able to see it right here. If you need to print it out, just scroll down to the guided notes today, which is going to be right here. And that is your guided notes. Okay, so you can print it out on page 13, or if you want, you could just copy it down on a separate piece of paper. Either one works for me, so I'm not going to be too picky about that. And then take a picture of it and then just upload it to MS Team, and we should be good with that. So let me go ahead and attach this one here as well, so that way 6th period has it. All right, so let's go ahead and go back to our guided notes. So this is going to be just a quick little SEL thing. It's going to be on the fixed mindset versus the growth mindset. So what I want you guys to do on the brain right here is that with these phrases, this is too hard. What's a growth mindset phrase that you can reword it to make it more positive? I can draw. What is another way of saying that? His is better than mine, and she's naturally talented. It would take too long. I made a mistake. It's gone wrong. So I want you guys to go ahead and translate that language into a growth mindset statement. Okay. And then I want you guys to come up with some scenarios. What should I tell my brain? I can train my brain. What should I not tell my brain? And I want you guys to go ahead and give me 3 each here. And actually, these are the statements. You can go ahead and just put them right there. Okay. Next is the bottom one, and it says, my mindset really matter. Give me your name. Think of something I think I need more practice on. 3 things that can make me awesome. Something new I would like to try. Something that takes a lot of work for me is, and something that is pretty easy for me. Then on the right side, you have your change your mindset template. So I want you guys to go ahead and choose to look for the good. I changed my mindset by, then list the things there, and I got caught in a crab trap when it blank, blank, blank. Okay. All right, so with that said, let's go ahead and jump into the 3 examples we're going to talk about today. It's going to be on 5.4, probability and the central limit theorem. All right, so let's go ahead and take a look at this. This is finding the z-score where the sampling distribution is going to give you this formula right here. And the one that I'm going to be using is this one here. Okay, so the x bar minus a u over the standard deviation. So take a moment and take a look at example 1. Example 1 says the IQ scores have a normal distribution with a mean of 90. So your mean is 90. And a standard deviation of 11. And 9 students are randomly chosen from this high school. So your N, which is a sample size, is a 9 high school students. A, it says 1 student from the sample has an IQ of 120. What is a corresponding z-score? So remember your z-score with that formula is going to be x bar minus u divided by the standard deviation. So then let's go ahead and plug this in. So X bar is going to be the 120. So I'm going to put 120 minus the U, which is going to be 90, divided by the standard deviation, which is 3.7. So grab your calculator and subtract the numerator. And then go ahead and divide, and then tell me what is your z-score. Okay, so then looking at this part right here, that is your z-score to the corresponding thing, okay? To the corresponding question. Oh, and before you do that, you're probably like, wait a second, Callahan, how the heck did you get 3.7? Because isn't the standard deviation 11? Well, you got to be careful with this because this is a standard deviation with the X bar. To find the X bar standard deviation, you did this from the last lesson from week 16 Monday. And this is a special one because for that one, the standard deviation of X bar, and I'm going to go over this with you guys right here, is actually going to be equal to the regular standard deviation divided by the sample size. So the regular standard deviation is 11 divided by the sample size of 9 students is 11 divided by 3. So then your standard deviation of the X bar is actually 3.7, okay, which is exactly what I need for the z-score here. And that's how I got 3.7. So if you're like, how did she get that? Well, now you know. All right, let's take a look at B. It says another student has an IQ of 84. So then that's going to be your X value is 84. And then what is the corresponding z-score? So then looking at this, you know your z-score is going to be equal to X bar minus sample size of U X bar divided by the standard deviation X bar. So then your answer here is you're going to use 84 first minus your UX bar, which is 90, that was given from the example, divided by your standard deviation X bar, which we just found is 3.7. So go ahead and calculate that with your calculator. Type that in, and you should have a negative 1.62. And these are your two answers for your z-scores. Now, if you want to see whether this person is above average or below average, you can go ahead and use the z-score, draw a bell curve, and then find that on the z-table, like we did last week. All right, let's go ahead and take a look at example 2. It says a national mean weight for an 8-year-old boy is 72 pounds. So I want to make sure I write that down. So the mean age is 72 pounds. And if you look at this, we're actually going to be graphing it on this one. So 72 pounds with a sample standard deviation of 5. A sample is taken of a 48-year-old boys, so the sample size is 40. Find the probability of one of these 8-year-old boys weighing less than 73 pounds. So, what first we're going to do is let's go ahead and maybe find the sample, the standard deviation with the X bar. So your U X bar is going to be 72. Your X, which is given from the equation here, is 73 because you want somebody who's weighing less than 73 pounds. And then your standard deviation X bar is going to be using the formula, which is going to be regular standard deviation over the square root of n, which is just 5 divided by square root of 40. So I'm going to give you guys a second. Go ahead and tell me, what is the square root of 40? That should give you 6.32. And then you're going to go ahead and divide that in, which should give you a 0.791. So let's go ahead and proceed in finding the z-score, which is going to be the X bar minus UX bar over standard deviation x bar, which is going to be x bar is 73, because you want to know how many kids are going to be less than 73 pounds, minus the u x bar, which is 72, over the standard deviation x bar, which is 0.79. You could put the 1, but I didn't. So 1 divided by 0.79 is going to give me a z-score of 1.26. All right, so then with this one, let's go ahead and graph that. So I'm going to do this on a separate piece of page so I can blow this up a little bit bigger so we can see a little bit better, because, oh, you know, actually I do have it here already, so that's good. But I'm going to need a little bit of information. So I'm just going to take this work that I already done, and I'm going to go ahead and paste it over to here. So I already have this information readily available. Okay, so here we go. Let's go ahead and label this then. So I know that the middle is going to be my mean. Let's use a different color. And I know my mean is going to be at 72. And my z-score is at 1.26. I know that my standard deviation is going to be at 5. And so at +1 standard deviation, it's 72 plus 5, which is 77 pounds. At +2 standard deviation, it's 77 plus 5, which is 82 pounds. And at +3 standard deviation, it's 82 plus 5, which is going to be 87 pounds. Okay, so those are all the positive standard deviations that's given to me. Now let's take a look at the negative standard deviations on the left side. So that -1 standard deviation, that's 72 pounds minus 5. So that's going to give me a 67. And -2 standard deviation, that's 67 minus 5, which is a 62 pounds. And -3 standard deviation, that's 62 minus 5, which is going to be a 57 pounds. Now, the boy that you have says, how many, or what is the percentage or the probability of the kids that it's going to be weighing less than 73 pounds? So right here, probability of one of these boys weighing less than 73 pounds. So let's go and figure out where 73 pounds is even located at first. So 73 is going to be right here, kind of by a little bit over 72. Okay, and this is where 73 pounds is. Since they want less than means it's going to be this way. So I want to find the area of this area here, from the red line all the way to the left side. And it's kind of nice because it's only from the red line over to the left side, so you actually don't have to subtract anything like when you have two lines and you're finding the in-betweens. So it's also given to me that my z-score is 1.26, so let's go ahead and look at the z-table to figure that out. Okay, so 1.26 is right here, 6 is right there, go down, go over, and it is 89.62%. Okay, so then everything here is 89.62%. So 89.62% of 8 years old weighs less than 73 pounds. And that's how you would answer this question. All right, let's go ahead and go on to the next one. which is example 3. Okay, so here's example 3. Go ahead and take a moment and read this. It's given to you that the graph shown the length of time people drive each day. Personally, I get up in the morning and I drive to Hug, and I'm about maybe like, I don't know, like 17 miles away. And then takes me about 15, 20 minutes to get to Hug High School. And then afterwards, I kind of go back to pick up my kids and then move forward to going back home. So I drive about on average, I would say about like 45 minutes a day. But here it says you randomly selected 50 drivers. So automatically you know that there are 50 drivers. So then my N is 50. And their ages are 15 to 19. So if you're a 15 and 19-year-old, you probably don't have children, so you don't have to pick up your kids. So your driving schedule will look a little bit different than mine. Maybe you're going to go to the mall afterwards. Maybe you have to go to your job. Maybe you're going to pick up your sister. So who knows? Your driving schedule might be, vastly different than what I do. So what is the probability that the mean time they drive each day is between, and this is going to be your X, okay? And it is going to be between X bar is 24.7 minutes, and so that's your X bar 1, X bar 2, 25.5 minutes. Those are very close minutes. And it's given to you that the standard deviation is going to be 1.5 minutes. And your average, if you look over here from this chart, because it actually doesn't give it to you in the example. So you have to look at the chart, it's 25 minutes, the average time that speed driving each day by age group. So yeah, it looks like if you're 15 to 19-year-old, which you guys are, you guys drive a lot less time than somebody who's like, in my age group, which is right there. I'm older than 25, but I'm younger than 54, who drives 64 minutes. And then of course, if you get older, you probably don't go as many places because you're retired, you don't need to work. So you drive 39 minutes. So I thought this is kind of interesting. I don't know, like I drive about 45 minutes, I think on average, but 64 is okay. And then it's given to you that your average, so UX bar is going to be 25. Okay, so now that you have this information, we're going to take that information and we're going to go ahead and plug it into the z-score. Okay, so first I'm going to do is I'm going to find the z-score. Z-score is going to be X bar minus UX bar divided by standard deviation X bar. And so then looking at this part here, we're going to have to find the standard deviation of 1.5, but then I also need to figure out what the standard deviation X bar is going to be. And the standard deviation X bar, you can actually find that using the formula that we just went over before. So your standard deviation X bar is going to be the standard deviation over the square root of n. So if my standard deviation is 1.5, then what is my n? My n is 50. So I will have to, whoops, I'll go back. So then 50. So then plug that into your calculator. 1.5 divided by the square root of 50. Which is going to give you a standard deviation X bar of 0.212. Okay, this is not changing colors. 0.212. Okay, So now that I have this newfound information, let's go ahead and plug it in. So this is your Z1 because you're going to have two different Z-scores given the fact they have two X bars. So your Z1 is going to correspond to this one here. So it's going to be X bar 1. So that's going to be 24.7 minus U X bar, which is 25, divided by your X standard deviation X bar, which is 0.212. So let's go ahead and calculate that. And that's going to give you a negative 1.42. So that's your first Z-score. Then let's go ahead and find the second Z-score. Z-score 2 is going to correspond to X bar 2 minus U X bar divided by standard deviation X bar, which is going to be your X2 is right here. So 25.5 minus 25 divided by 0.212, which is going to give you a 2.36. And those are your two examples. So I'm going to go ahead and take a photo of this so I can go ahead and move it over to the examples that we just had. And then let's go ahead and draw the graph. All right, so then looking at this part right here, let's go ahead and label everything. So we want to figure out what percentage is going to be in between 24.7 minutes and then 25.5 minutes. My mean here is going to start off at 25. Remember, my standard deviation here is going to be 5. So then at plus 1 standard deviation, it's 25 plus 5, which is 30 minutes. At plus 2 standard deviation, it's 30 plus 5, which is 35 minutes. And plus 3 standard deviations, 35 plus 5, which is 40 minutes. Similarly, on the left side, 25 minus 5 is going to be 20 minutes. Minus 2 standard deviations, 25 minus 5, which is 15 minutes. And minus 3 standard deviations, 15 minus 5, which is 10 minutes. So the area that I want to find that's in between this is between 24.7 and 25.5. So 24.7 is going to be like right here. 25.5 is going to be like just slightly a little bit over, which is right there, 25.5. So I really just want to find the sliver of area that's right here. Now I want you to have their Z-score. So your first one is going to be 1.42. Your second Z-score is 2.36. So let's go ahead and take a look at the Z-score of negative 1.42. So negative 1.42 is at 7.78. So I want to go back to this and write 7.78. So 7.78%, and that represents from this part all the way over to the left. And then my second one is 2.36. So let's look for 2.36. And that corresponds to 99.09. So this one here is 99.09%. One second, 24. Okay, so then what are you going to do with these two? You're going to go ahead and subtract it. So subtract the 2 here, and that is going to give the answer of the area that's in between this sliver here. All right, you guys, that is basically it. As always, stay safe and healthy, and I will see you guys next time. Take care.